Hey guys, it's better with the microphone. It's Christopher, welcome to this Solarus live streaming. Today we are going to improve the Solarus engine and work to work on shaders. So this is a new directory in the development version, actually in a special development branch. It's very experimental. But
no, you can't.
The idea is to.
No, it's not me.
The goal is to add to support shaders in the next version of Solarus, in Solarus 1.6. So for now, I have a lot of examples of shaders. They all come, almost all of them come from existing emulators. So let me just start with the normal display here. Actually, it's still a shader. I can show you the code. Very simple shader that does nothing special. So shaders are a special language that will be executed by the graphic card to accelerate, to display special effects very quickly without any CPU. As of now, in Solarus you had some video modes, video filters. They were, for example, normal is no filter at all, no software filter and no shader. Then if we press F5 we can switch video modes. We had scale 2, which smoothens a bit the displaying. But this is a I'm almost saying this was because I will remove it from. Actually, all software filters will be removed and they will be replaced by their shader equivalent. HQ2X, HQ3X, HQ4X. Maybe you already know all of this in Solarus. And then we have the shaders. This is actually a shader I just added a few minutes ago. Displaying is a bit slow. Maybe there are things to optimize. Also, I'm running a debug version. All of this is highly experimental, but this one is very smooth, and it also preserves the quality of the details, like the eyes of the character. What else do we have? This one is funny. CRT curvature. No, CRT interlaced. So it looks a bit like an old TV.
Thanks.
Don't think it's very ideal to play like this, but it's mostly for the fun, let's say. And so yeah, every quest will be able to add their own shaders, which means that video modes will no longer be hard-coded. This one is just some curvature effect without the scan lines that we had in the previous one. So it makes me think of Mario Galaxy almost. It looks like we are on a planet a planet that is not flat. And next one default, so it's that one that does nothing. Edge detection. So by the way, thank you Valentin for your great work on shaders. He did most of the work years ago actually, and I didn't know shaders at that time. I didn't really know how to help him, but now I do. Shaders will be here, will be available in 1.6. So this one is, of course, I was going to say for the fun, but maybe you can imagine some special effect, like a night vision or something. And a future improvement will be to be able to specify a shader at every intermediate step of the display. For example, you might want to apply a shader on the map display, but not on the HUD here. You don't want your menus to be affected by shaders. I should set the volume to 0. Audio set music volume 0.
She smashed by
Could also have typed it here, but I always forget about that. Yeah, so grayscale. Don't think you need a lot of explanations about this one. This one is quite easy to understand.
Grandma.
We get the value of the pixel on the texture, and then we change it here. Well, it's not that easy to understand. You have some vector operations. Anyway, the principle of a shader is that you have an input matrix and a very small function main that is called for every pixel of the window, and you have to specify this built-in value, the color of the pixel. And graphic cards are specially optimized to run this kind of code for a lot of pixels at the same time, like millions of pixels.
Oh shit.
And this one is Heavy Bloom. And we are back to HQ2X, so, but this time is the shader version of the same thing. Valentin says that the result is slightly different, but doesn't really matter. It will replace the built-in one, and we have HQ4X and HQ Scale 2X as well, which is exactly identical to the software one. And this is a special project that I'm working on.
Mine is better.
I will explain that later. Is something missing here? Anyway, okay. That wasn't finished. We also have Sepia
Okay.
and Toon and Water Paint. So all these shaders are mostly to make some tests, but the real Mercury Stress game will have we will not have all of these funny shaders, but we will put them in the sample quest. Okay. So what are we going to do in this stream?
Oh.
We're going to do some C++ to continue the shader API. The first thing is that I need to pass some information to every shader. In particular, they need the size of, they need the texture, the input texture, of course. So this is already working, otherwise we wouldn't have seen anything. They need the size of this texture, and we will also add something that's missing currently. It's the size of the window, because strangely they don't have access to this information. Will it be possible to cascade shaders? Yeah, that's a very good question, Niglu. Not directly for now, but I'm really not a shader expert. 1 month ago I didn't know what was a shader, but what I know is that you can easily make a shader that uses some code from other shaders. But maybe that's not enough for your case. I don't know exactly what you want to do. But if there are some use cases, we will definitely consider it. Okay, Solarus on plus Solarus input size is not supposed to change, so I'm passing this information when building the shader, but one day it will change.
No.
Also, we pass Solarus display time. And normally my mode 7 experimental shader was supposed to use this information. Solarus display time. That, by the way, I will start by improving this. Let's try our mode 7 shader again. Okay, so the idea of the mode 7 shader is to display your texture with a perspective view. For now, the only texture I can access from my shaders is the quest screen, so it doesn't make any sense to display it like that. But later I want an API that allows from Lua to pass any texture to any shader. But yeah, my current problem is that this was supposed to be rotating with time automatically, because right here at is my Qt creator crashing. Anyway, every time I render the game, I pass the current display time to my shader. So let's check that it really changes every time. Display time. It was working a few hours ago, but maybe I broke something. Oh, I wanted to show you a better comparison of these smoothing scaling shaders. So this is without scaling. This one is scale to X. So it's a smooth effect, but only with a scale factor of 2. Then HQ2X, same thing, but much better, much powerful algorithm.
No problem.
And then HQ4X, this time it's a scaling factor of 4. It's very nice, but actually if you look very closely, the arms here are still edgy, the ears as well, this part of the hair, and it does not make really much sense that this part of the hair is very smooth and not this part. Then we have XBR filter. This one is really very smooth everywhere. Actually a bit too smooth for me. The outline of Link looks too... it looks like an egg a bit, but the real problem is that the eye is really wrong here, and both ears are very different. And the best one is what's his name again? XBRZ. Just perfect. The eyes are great. The hair is smooth. Both ears are identical. Everything I had to say about the previous versions is fixed in this one. So okay. And thank you Dark Neos for telling me about this shader, the XBRZ. Okay, let's close all these windows now. So, why do I not have any rotation here? Okay, so the time is updating correctly. So this instruction actually asks the shader. No. Ask the shader the location of this variable. It's not really a variable, it's called uniform because it will be identical for all pixels during one rendering. Solarus display time. So this should have a correct value, and in main I'm calling this function. So I found a mode 7 shader on the internet here, and I'm trying to adapt it. So I have this rotation here. Did I divide too much or something? I don't think so, and again it was working. Hi W Hughes. Oh, I don't remember your name. Oh yes, Will. This time it's in English. I'm trying to fix this shader issue. And in the final version there will be a more friendly user interface for shaders. We'll have, like in sprites, a left panel here with your vertex shader and your pixel shader, actually with the file names of both shaders if you have some, and in the right panel a text editor with just this part, or this part for the vertex shader. Oops. But this is this will be some data, and it's not supposed to be edited by hand. By the way, this parameter will disappear, we don't need them. Okay, I really don't understand why my Solarus display time is wrong. I don't think I have to declare it here. But let's try. No, no change. See? Did I pass this the wrong way? Display time int. Didn't change this code at all. Maybe I have to do this first. Oh, okay. So this was the problem. Okay, good. Let's revert this change. And I will show you the result now. Let's try it like this. So the idea will be to remove the top part here to make some horizon. And of course to control the movement with the keyboard of the mouse and not with an automatic rotation. But once we have that, we basically have the mode 7 of the Super Nintendo, like Mario Kart or Secret of Mana, when you were able to fly over the world.
I can play Golden if nobody wants.
You would just have to replace the screen texture here by any texture we want. And this will be really awesome. We have a nice... we have some ideas.
Don't pick up.
Okay, so let me commit this fix.
No. If you pick Oriel, they're gonna.
Okay, sorry. I want to just commit this fix. Fix Solarus time not correctly passed to shaders. And I no longer need this. Okay, what then? 8 pour l'instant. Yeah, I completely agree, Diarender. If you want to make, like in Secret of Mana, flying over the world, you can easily combine this one with the curvature one. Maybe I even want to try this right away. But first, I want to pass the real size of the window. Yeah, let's do that. No, first I want to fix this one because it's not computed correctly. Display time. Time since the current shader is displayed without interruptions. You already have this information. It's just supposed to be system now. Yeah. This base implementation will no longer do anything. Display time disappears. Don't need that. And instead of passing display time, we just pass system now. Yeah. Yeah, I had problems with one of the machines where I tested shaders. They were not properly working with SDL SDL 2.0.2, but it was fixed once I upgraded to SDL 2.0.4. Okay, it's still working, so the time still works. And by the way, how does the Mode 7 shader work? Well, the comments are nice. We start from screen coordinates, and then we have we turn them into a 3D point. So we add a third component basically, and then we make a projection back to a two-dimensional space. We perform some scaling and the rotation that you saw, and we also repeat the pattern. If I comment this line, it will be very different. Do we even see anything? Ooh. Okay, the rotation is gone again? Trust me, this is the expected result, but except that the rotation is gone. I only changed that. I don't understand. I passed system now. Is something wrong with system now? No way. Okay, so the values are correct. Oh, see, display time. Do I pass exactly the same values as before? Not really, but they are more deterministic. Maybe they move slower, but they should still move, right? Okay, now it works, so guess I forgot to recompile or something. That's weird. And what I was trying to show is, what if I comment this line? Okay. Okay, I have my rotation. So now the quest surface is displayed exactly only once, and the camera is like at the center of it. So we can only see a small part of the surface, and only when we are in a specific direction. And all coordinates that are outside the surface are actually take the same pixel value as the closest point, so the point on the border here. That's why you have this effect. But if we use the fract function here, we how can we explain that? I think we get the number between 0 and 1, so we get back into the coordinates of the texture. Something like that. But normally, there was something I wanted to try. I want to change to set a repeat mode to the target, so that what I was just explaining, the fact that when we are outside the surface, the closest point is picked. Well, this can change. We can configure, we can set up the texture so that it's automatically repeated. Where am I supposed to do that? I have to bind the texture, set up the sampler. Am I not passing the texture twice here? Get uniform location, Solarus sampler. Okay, no. Because here I'm only passing the display time. Okay. And later the window size. So bind texture. Render target. Get renderer, get how do we get this? Where is the render target? Okay, just video get render target. Okay. We have a mix of SDL and OpenGL code, so it's really complicated. I don't care about the size. Then I will do something and unbind. So after this binds means that whatever I do, whatever OpenGL operations I do, then they will apply to this texture. And what I wanted to do was wait, I have to find this. GL repeat. Do we do that again? GL text parameter. Target, it's render. I don't have the OpenGL handle to my texture. Let's cheat, just to test, because I know it's supposed to be 1. No. No. It's not that, the first parameter. I don't need to specify the texture precisely because of what I just said. It will apply to this one. It is the current texture in the OpenGL state. P name wrap. Please wrap my texture. I mean, I will set the wrap mode of the texture, and the value is GL repeat. There is wrap S and wrap T. What do they mean again? Okay, texture coordinates S and T. So this one is horizontal and this one vertical. Anyway, I don't actually want this on all textures, but maybe I will make an API to enable it at least with this shader. So as you can see, now the texture is automatically repeated, and that line is still commented. So unnecessary if GL repeat is set on the texture. So I don't know yet if I will make an API to allow this. We will see. Okay, so it's nice to see this working. Don't know. I won't enable it for now. It was just a test. I forgot to commit the change about the time. I also wanted to rename the Solarus display time value. It It should just be Solarus time. But now I have to update all shaders where this name was used. Solarus display time. Okay, only have it in 2 shaders. This one, of course. And CRT interlaced. Fragment shader. Uniform display time. Wait. Okay. And now okay, it's still working. No, it's not working. Is it? I forgot to compile. By the way, let's put this back. Okay. Time to commit. Okay, next step is the quest size, because a lot of shaders need, I mean the window size, they already have the quest size, which means the 300 by 320 by 240 logical texture that they have as input. But the actual window size may have basically any size, and some shaders want this information to properly work. For example, this one wants the resolution. For now it's hard-coded to this, which is wrong as soon as I resize the window. Let's see this rotation again. The top part is slightly darker because of this code, darkness based on the horizon. H is the height of the horizon measured from the center of the window. So 0.25 from here, and if I resize the window, actually the horizon will no longer be here. Now it's almost at the in the middle of the window, and this problem is because of these hard-coded values. So what I'm doing now is that I will just pass the size of the window as a uniform variable, just like I already passed the quest size. It will be similar to this code, but I will pass this at every frame because it might change sometimes. Window size, there must be a get window size function. Yes. Location Solarus output size. Okay, and that's it. In my shader now, I will just have to use Solarus output size and declare that size as a uniform. The funny thing is that this one doesn't even need the input size. So it's a vector of 2 elements called output size. Okay, so there shouldn't be any change in this size of window, but when I make it bigger, okay. This time the result looks the same. And resizing the window doesn't change it. Okay, so it works. And there might be other shaders that want the information, in particular the smoothing one. Now that I have it, let's give them the correct value. Yeah, instead of setting output size to the input size, output size will be defined like that. No, Solarus output size. And I have the same code below. Hope I'm not changing anything. Let's check at least all XBR ones. This one uses input size all the time, even when it was output size in the previous code. So oh wait, I guess I will have to check that later. And actually this is some code generated automatically from a different format of shader, so it's completely unreadable. But this one is the most important one. Okay, let's see what it gives. Okay, do I have a black screen? A white screen? Yeah, what did I break? I didn't even change this shader since last time I tried to make a test. Resolution is output size. Let's remove this.
stream.
Mais si.
Je parle pas.
Ça serait plutôt... it should be integer here. No, float, okay. Okay, this time it's no longer a black screen. Again, I'm not sure if I changed something, but I wanted to check the XBRZ because it's the one I just modified. So I have this slight problem in full screen. There are these line artifacts which might be completely unrelated to shaders actually. It's an old bug of the engine. But okay. Let's continue to play with our mode 7 shader. So we have a few parameters. This is the height of the horizon. If I set it to 0.5, it will be the top of the screen. Mode 7. So this time we don't have like a ceiling with a mirrored image like we had before, but we don't see the end of the horizon. So that's why this darkness effect can be nice. I will keep commenting the initial value and set the actual one here. And scaling is how close I am to the texture. For example, if I say 0.1, I will see yeah, much closer. And if I say like, I don't know, 5, I will see a lot of tiling. This is absolutely ugly. Ugh. Let's keep the default parameters, they are nice enough. But yeah, one day we'll be able to put the surface we want, and the rotation will be controlled by the player instead of automatically with time, because it is just for testing. And also, of course, we can change the value of the scale to make the player move upwards or downwards. Okay, next step. What else do I want to do? Several things, but I want to remove these parameters. And for backward compatibility I will have to add HQ3X as well. Okay, so let's open all these files and kill the two parameters we don't need. We discussed this with Valentin a few days ago and we agree that they are not needed. Because the name of the shader is already its ID here. And the window scaling, Lua scripts can always call set window size to change the scaling as they want. It's not the role of the shaders to change the window size, even if when you call set video mode so far in current versions it does change the window size to what we think is the best size for this video mode. But this will be doable from Lua. Okay. Then when we parse the Lua file, we no longer need name and we no longer need default window scale. Shader name. I don't know if this is used, but I have to pass the shader name like I do from other types. I mean, for other files that I parse. Fail to link shader. Yeah, I will have to kill this as well. Shader name and default window scale. Goodbye. Or maybe not. This is shader ID. File name without extension. Exactly like maps, sprites and everything. Sampler type, this is no longer used, and this is no longer used either. Okay, in the constructor let's set file name without extension. Shader ID. Oops. It's used here to compute the file name. I will also rewrite that to make it look more like sprites and everything. Oops. Shader ID. This is wrong. Shaders are not necessarily video modes. for now they can only be used as video mode. That's a slight difference. Default window scale, we do not care anymore. Get ID. Oh, what is this protected and not private? Let's keep this field private. Also, it will be const. Get ID is const. Shader name is no longer needed. Get ID const. What's wrong again? Okay, load. Very good. And in the load function, I need to call get ID. No, okay, I already have it. I'm in the correct class I'm in. Video mode name. This is where I used get ID. So yeah, for now all shaders are added as possible video modes. But actually, which means that they are all compiled when you start Solarus, but actually we will only load them on demand. Get default window scale. Who cares? Don't want get window scale. Video. Okay, it was used here. No automatic window size change. Okay, so now it's the size of the window is now by default the size of the texture, size of the quest, 320 by 240 in this project, and I can resize it like I want. Now if I change the video mode, okay, it was resized. Ah, okay, it was resized to the value I passed here, which is not nice. Yeah, but one thing after the other. Remove unnecessary shader parameters. I will just kill the built-in video modes. And this as well. Yeah. But first I have some code to clean here. Oops. Shader. Let's see how it is done in actually there's a sprite data, tileset data, map data. I need such a class. Also to be able to change that data from the future user interface. Include Solarus low level. Shaders, shader data. Okay, let's tell CMake about this. Library. And since this is a different directory, I want to put it before. Later I will also move the shaders directory outside of the low level directory, but that's just a detail. Okay, shader data. Let's see sprite data. Copy and paste. I need common Lua data. We will see about these ones. Namespace Solarus. Stores the content of a shader data file, which is a very special file actually. This file with one video mode function and two properties, fragment source and vertex source, which is optional. And there were other properties before, but I just removed them. So it will be very simple. Shader data. So for now, fragment source will be directly the text of the shader source code, but later it will be a file name in order to allow to edit this as a separate file. Yeah, shader data. We will have these functions, of course, and the air shader that we have in the other file will come here. And the data will simply be I need string. And well, Lua data already has this include. It also has string, of course. But we have two things. Vertex source of the vertex shader and fragment source. Okay. Then oh, the copyright date is wrong here. I thought I had a global replacement for that. Okay. Namespace Solarus. I need getters and setters. Void. Like this. Declare in the class itself. Hello again, Zelda Retro. Okay, so I only have two fields. Vertex source, which is empty initially, and fragment source the same, except that this one is optional. Returns, sorry. Let's say it's also the vertex shader or an empty string. Because it's optional. completion is not working. Shader data does not limit type. That didn't help. Let's add some indentation. Yeah, low level shaders. Okay. Now, replace vertex by fragment. Okay. And now the actual work. Export to Lua will not be used in the engine itself, but only by the quest editor one day. Export animation to Lua. So actually we want to generate this kind of file. It's really easy. I have to take care of generating a multi-line string. Let's see how I do that in another data file, which is dialog. There is no dialog data. Language maybe. Where is it again? Low level. I don't remember. String resources. String resources is Lua data, so there must be dialog resources. Okay. Dialog data. And dialog resources, which is a data file. What was I looking for again? Export to Lua. Yeah, just to have this syntax. Oh yeah, there is an escape multiline string function. Shader. So I want to generate this. Oh, it's video mode in my shaders. No. Can't stay video mode. It will have to be shader. Because again, one day we want to use them for at other steps than only the final rendering. So they are not necessarily video modes. It's a bit annoying to have so many shaders at this stage of the development, because we often have a lot of things to change, and apparently I forgot to remove these. Shader, and shader. Okay. I don't have to print the ID. But make sure that the closing is always in a new line. Yeah, let's do the same. should factorize that. I can make void export multi-line string field name value and I don't know why these ones are not const references. Oops. Okay, and my new function, I'll just do the code that we saw. Export multi-line string. Qt curator generates comments with arrow-base. Place, find, place. Shader data. Let's try to write. Okay, and what was done here? Just wanted to move it there. So instead of text is field name, equals next line multi-line string if value is not empty and is not finishing by a new line. I put a new line before the closing marker. Okay. It's to make translations easier. Actually, I don't really care because for shaders, right now it's a multi-line string, but it will change soon to be a file name. Dialog resources. Export multi-line string. Text out. It also makes the code easier to read. Then I export a multi-line string field. No, Lua. Vertex source. Get vertex source out. Okay, but only if it's not empty. Well, we actually it's just a field. If not vertex source empty, we export it, and then we export fragment source unconditionally. Oh wait, I have to add this. Exporting the field completely. New line between both of them, and the problem is that I need a comma here. I need a string. That's slightly better. Dialogue. Now let's see. Something easier. Animation. Properties of the shader. So let's take the code that is this will disappear. Loading shader. No need for global state. Okay, it's here. Boom. And boom. Okay. Let's start with this one, with the import from Lua, because it's the one calling this indirectly. Shader load. I think it should be very similar to this. Okay, so I have a Lua state. Here's just the Lua context of the shader file being parsed, because this is actually Lua. And so I put the current object, this. I indicate the pointer to the current object to the Lua world. I register the shader function, this one. I call the file, okay, and if it failed to load shader and a proper error message. And now my function here, it just needs to get the pointer back, since it's a static C function. There is no this, so to get the this, I do essentially that. Get field shader from this global table, this internal table called the registry. And I know that it is a shader data pointer because it's the one that I put there. And okay, then I can work. Loading shader name, actually it already knows its own ID. Shader. Program Wait, loading shader was... what was the type of loading shader? It was GLRRB shader. Handle ARB. When was this created? Loading shader. Loading shader equals this. Okay. Register callback. But now it's really not the time to do that. Not at all. Yeah. So we have two fields, vertex source, which has a default value directly hard-coded like this. Why not? But let's at least add some new lines. Fragment source, this one is mandatory. Well, I will create the actual executable shaders later. Oops. Set vectors, vertex source, and I have some indentation issues. Fragment source, okay, and when this is called, my shader data object contains what it the source of both shaders. Lua push like this. What? Okay. Okay. Maybe I don't need Lua tools, but at least Lua. Debug has not been declared. This function is const It's a bit less fun than the beginning of the stream, because I'm doing a lot of refactoring here, putting the code to handle this format in a separate class. Okay. Bool. Return true. Not true. Lua tools. Oh, so okay, I actually did need Lua tools. Print data. What? Great error messages. Why was this code working in another file? And actually no, it was not even in another file. Well. Discard qualifier. No, this is a static function. Const and std string, that's what I changed. Oh, I did change the parameter, that's why. Okay, so let's keep it that way for the moment. This is really outside the scope of shaders. I want to compile from my console to choose how to parallelize the compilation. Okay, so I removed a lot of code and I will put it back in the load or load Lua file function. Text. It's not text, it's value. sprite. Must be sprite animation set. There's a load function, like the one we saw. It decides a file name, create a data object, and just calls the import function. So all of this code is already handled by my Lua data class. Can remove load Lua file. Load the shader data file. File name. Then shader data. Import from request file, and if success. If not success, there will already have been an error message, I think. So if success, now we will put the code back. So what did I remove? I removed that. I removed that. Create the vertex and fragment shaders. Except that I'm in the parent class here. But anyway, this is the code. Why is this a reference? Vertex shader, fragment shader. This was, I guess this was supposed to be done after. So let's make this a virtual function. This one is no longer needed. Because the code is dependent from the shader implementation. We think we will have two implementations. And by the way, is it public? A traditional OpenGL implementation and an OpenGL ES implementation. For embedded systems, unfortunately, there are some slight differences, but we hope that shaders will be compatible from the user point of view. Void load override. Okay. So, shader. The function I was currently writing will go to the other class. Maybe it should be one of the first functions. Okay, this time we need get ID. Okay, import from quest file. Shader file name. If success. Well, if not success, return. It will be easier to read. Vertex shader. Okay, so we have the real OpenGL objects here. We create a vertex shader. Compile shader. Vertex, so this one is. Oh yeah, it's in shader data. Get vertex source CSTR. Include shader data. It returns the cons reference, so it is safe to call CSTR like this. Get fragment source. Compile both shaders into a shader program. Link. Check the result of the link. And what was it supposed to be used for? Loading shader. Ah, okay. Just to change their value from the static function. Okay, no need. I think we are close to finishing this refactoring. Void load override. What's wrong? Invalid new expression. What do you mean? This is not an abstract class. Because the following virtual functions are pure oh, okay, which one? Virtual void Solarus shader load. That's not true. Oh no, it's the other class. Okay, so I don't want to touch it because this one is for OpenGL ES and Valentin might be already trying on it, working on it. So let's don't add a constraint like this. We will make a temporary implementation of load that does nothing. Shader load. Back to the future, yes. Register callback. Don't care about this one. Hi, Michelle. Okay, it's compiling. I guess I broke some unit tests. Actually, I even hope I did. Let's see. Oops. Yes, I did. It's because in my refactoring I changed something really unrelated. I factorized some code into this function, and the difference is that now I add this comma, so the generated dialog files are now slightly different. So it's not really wrong. I always add a comma after my fields in all data files. So it was a bit strange not to add it for dialogues. I will just update the reference file in the unit test. It's very, very, very important to have unit tests that check that when you open a file, do nothing and save the file, it hasn't changed. You don't want to lose information. I have to recompile the quest editor. So I will also make a unit tests for the shader format. But not today. I just opened an issue so that I don't forget. The quest editor is still compiling. I'm not compiling in parallel because my computer is already overloaded. Okay. I can still check that the engine runs correctly after the refactoring. No, it doesn't. I have a lot of error messages. Can't compile shader, can't compile shader. Guess I broke everything. The first error is failed to link shader fragment info. Okay, I think I understand. Vertex, 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 fragment, 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 fragment. Maybe get fragment source returns vertex source or something like that. Touch object. Fragment source, vertex source, fragment source. Okay, and when I import, okay, this is the mistake. I was doing set fragment source, vertex source. Okay, it's still working. So my only problem before I commit was the unit tests. Testing quest. If I open the testing quest, I must have some dialogues. So let's do nothing. And save. Okay. So the comma was added after all dialogues. Let's check the unit test again. It was language data. Okay, passed. Time to commit. That's the first step towards a shader editor in the quest editor. Well, when I say shader editor, it will be something very basic. It'll just generate this part automatically and allow you to choose your both your shader files. But later maybe there will be more parameters. We are not very sure yet. Shader data. Okay. I don't remember what was the next step I wanted to make after moving this code and implementing the export feature. Uniform location, window size, that's done. Yeah, I want to kill the built-in video modes and make a new set video mode function that takes the name of a shader as parameter. Pixel filter will completely disappear with all its subclasses. We had HQ 2x, 3x, 4x, scale 2x, and that's all. Yeah, just kill everyone. I will open an issue to about adding an HQ3x filter as a shader because it's still missing. For retrocompatibility. Milestone 1.6. Okay. CMake. Let's kill these guys and this one and pixel filter. It also means that OpenGL becomes mandatory, at least if you want some nice graphical effects. So, removing the files, pixel filter, HQ, everything filter. And by the way, they were quite fast even if they were software filters, except the first time you run the HQX filter, because it had okay, it's already dead. It had to initialize a very big lookup table, something like that. Scale. Okay. Pixel filter, scale to X, HQ, whatever, filter. Okay. Video mode. How will we do that? Sol.video.set mode. Maybe it will be renamed to set shader. But for now we can keep that name in the C++ side. Name, there is no longer an initial window size. And hardware filter. Let's just say shader. Get name. Is there really a name? No, it's the name of the shader. But then is this class still useful? Maybe it's no longer useful at all. Yeah. Okay. Video mode. You're gone. Boom. Just like that. Okay, and in video we have get video mode, get video modes. Is video mode supported? there is no longer a video mode notion. But instead there will be shaders. That's the big idea. For example, who calls this function? Settings. Yeah, get video mode by name. So it will simplify all the code. Let's keep a switch shader function, set default shader. I'm not sure about that. Is mode supported? We will see. Get shader ID. Switch shader. How can we do that? Because I don't want all shaders to be implicitly video modes. But then I guess just don't call the switch shader function. Okay. Get shader ID. I already have this from the resource system. And set shader. Maybe set window shader ID to indicate that it's the shader applied at on the whole window, right? On the final rendering stage. I'm not sure. Set get shader ID, set shader ID. Oh, there is full screen. Just use set full screen for that. This function is not used. It's a special class where everything is static. Shaders enabled. Okay, string current shader ID. Okay, I still need to store the list of all shader objects. That's right. So I still have std vector shader. Our map. Hmm. I should put this in the resource cache. Yeah. Didn't use this a lot so far. Only for tile sets, because it's not finished. Shader. I have to include Solarus, low level, shaders, shader. Provide the shader with a given ID. Shader ID. How do I create a shader? Because there are several subclasses. Anyway, shader. Load. Isn't this already called automatically? Yes, it is. So there must be a condition somewhere to create one type of shader of the other. And actually this condition is actually always true for now. Shield. No. Who calls this? I don't remember. Shader context. Ah, okay. Ah, so this is why there is a shader context function. Okay, interesting. So that's very clean. We can just call this shader context class. Shader context, but of course I need to include the file. No. Shaders, shader context. Maybe I will rename this class because it was not doing what it its name suggested, actually, at least to me. Shader ID. It should also be called shader ID here. Unique PTR, that is great. Perfect. Perfect, return shader. Okay. And when I need a shader somewhere, I can just ask the resource provider to find it or create it. And it won't be recompiled every time. Okay, of course I can't compile at all. I barely started this refactoring. Initialize video modes. Decide whether we enable shaders. I need to rename default to normal. Again for retrocompatibility. And we are exactly working on this to do. Render target. It will be more initialized video feature needed for shaders. We need this render target object, and what we don't need is to initialize all shaders right now. Create only on demand. So I think I will just kill everyone here. Yep. This function no longer does what its name says. Set quest size range. Don't care about this order now. Initialize video modes, whatever it does, no longer has to be done later. Because set quest size range is called by the main loop. Oh my. Yeah, it was also something very strange, but we didn't really have a choice. Anyway, wherever I initialize a window, I can also video initialize. I can also do the rest. Disable window. Okay, I'll create window, create a renderer, and then decide whether we enable shaders. Additional video features needed for shaders to work. Okay. I like this. by. Current shader. How do I call it? Current shader ID. Okay. To the gray surface, if any. So it will just be the string. No, it should be a pointer. Is initialized. Huh. How can we know? Can't really test the window because Solarus can be run without any window. For example, for unit tests. But we can check pixel format because it's always there. Main window or window PTR, renderer, render target, pixel format. This one is no longer needed. Well, we are simplifying the code. Oops. Is full screen, set full screen. This was really ugly. Set full screen. Store the window size and then what? So I removed this. I need to store the information. If not, disable window. Don't think we need to do all this. Set the full screen fly first. It's when you change the video mode, but you also change the size. It will be simpler in the new implementation because we no longer automatically change the size when we change the video mode. I mean when we put the shader. What? Ah, it's also set video mode that changes the cursor. Oh. Mm-hmm. Set. Okay, SDL show cursor. Invisible cursor was just the global parameter. Okay, I will have to re-implement this function completely, I guess. Actually, it's the function that gets called when I press F5. Okay, I will just kill all this code. If current shader. Oops. And no software filters, they no longer exist. Just quest surface. So if shaders are not supported, this code will still work. And the rest shouldn't change. Restores the default size of the window for the current video mode. Who needs that? There is a reset window size. I didn't want to break compatibility with Lua scripts. Okay, what I can do is set window size. I can keep the function existing, but do something more predictable. Just reset it to the quest size. So back to video. Reset window size no longer exists. I just have to implement these functions. Place the specified shader to the window rendering. Or an empty string to set no shader. Return, well, let's say nothing. And we'll see if we need something one day. So if shader ID is empty, well, I don't know, it seems too easy. Resource provider. Is static. No, but I can use current quest, I think. No. Who can give me the resource provider again? The game, the main loop. It's attached to the main loop. It should be attached to the current quest. Yeah, there is this current class. I mean namespace. Oh, static. Resource string dialogues. Why would we have static order initialization problems? Yeah. I don't know. Actually, resource provider should provide this kind of stuff because these are resources already. Provider. Okay, this case is also used by the quest editor. Okay. So at runtime, I mean, actually, all of this is static information that the quest editor can use, but this only exists during a main loop, because they provide loaded maps, loaded tilesets, loaded shaders. Okay, so there is, I understand why I did this choice. We are really depending on the context of the main loop. So I guess I have to keep a reference to the main loop here. For example, the Lua context wants the main loop. So I'm gonna have to do the same. System initialize. maybe const. I didn't want to have to do that because it's the main loop that is supposed to depend on low-level features, and it's not the job of the low-level features to keep to take care of the main loop. But actually they probably have to. Class main loop. Should reorganize this one day. I'm not sure how. Okay. So, current shader all of this was just to get the resource cache. Get resource provider, get shader ID, and what if it doesn't exist? What are they? Okay, they create a new shader. And it's actually a null pointer, and I return a reference to a null pointer. So that's very bad. And why didn't I check the same thing for tilesets? Upload. Don't even see where I test the existence of the tileset. I think I tested. I must test it here. But oh wait, new tileset ID. What if it doesn't exist? Don't really care for now. But then we load it. If success. Okay, then we survive with the tileset object that is not really valid. But here we don't survive at all. Let's slightly change this function. But then maybe I should do the same for tile sets one day. Because it's too complicated. Null PTR if such a shader does not exist, or if it fail to compile, or if shaders are not supported. Okay. Shader context create shader. Turn unique PTR. Time does not match. System initialize const main loop. Doesn't name a type. No problem. Const. I wanted to keep this one const if possible. But I guess it's not really const if I... No, it's const. But there is no constness at all in this in this class. So no need to bother. System. Maybe I will find a cleaner way at some point. What? Save. Oops. Okay, still a lot of files to recompile. Let's finish this one. If current shader does not exist, return an empty string. Return current shader get ID. ID or an empty string. Cannot convert Solar. Okay. So after all, it was not const. Cannot convert the main loop to main loop. So get shader. Why would it return a const shader? Const tileset. I have constness issues. There is no way to pretend that this tileset is const. Okay, bye Zelda. I think I will stop the stream soon. Just want to finish this work on removing built-in video modes. Get mode, set mode. shader ID. String shader ID. But std string to keep compatibility. Okay. To avoid conflicts, I will change my mind about this one. And this function should be deprecated. How do I make a function deprecated? I have a few examples. Map move camera, for example. Warning, deprecated. Video API. Sol video get mode is deprecated. Use sol video get shader instead. Sol video set mode is also deprecated. Use set shader instead. Of course, this function does not exist yet. There is no shader type in Lua yet, but I will do this maybe tomorrow. Mode name. Also, I should check that there is a change here. If shader ID equals get shader ID, return no change. Okay, back to video API. Mode name. So if mode name is the string normal, it means no shader. Set shader ID, nothing. Else set shader ID mode name. Okay, then I could do mode name equals normal, an empty string, or mode name. Return 0, and what happens if it does not exist? Current shader, it will be null ptr. Okay, so the behavior will not change. And switch shader, I'll keep this for tomorrow, even if it's easy. It's getting late. Switch shader. Oh, there is also a get modes. I have to deprecate all of this. And even is mode supported? Okay. Switch mode, switch. Maybe there will be a switch shader function. Not sure about this one. Switch. Then get modes. I don't know the replacement yet. Let's say get shaders. But I'm not sure. Return 0. I will have to re-implement this function. All these functions will be deprecated because there will no longer be a notion of video mode. Unless I change my mind and I decide to still call them video modes in the Lua side. Is shader valid? Maybe something like that. Function that will also check that the shader correctly compiled. I can implement this one. If mode name is normal, push boolean true, return 1. Otherwise we want the shader get shader, just get shader. No, resource provider. Need a main loop. Get resource provider, get shader, mode name. And supported will be just shader different from null PTR for now. Push boolean. Okay. Is full screen, set full screen, the other functions of course still exist. A resource provider was not declared because I removed it. What was wrong with 80-second get? I don't like to return a raw pointer like this, but it's just because it's an optional value. Null PTR. Return null PTR. Then what's wrong again? Syntax issue. Okay. Settings. Set from quest. Sets the settings to the one of the currently running quest. Okay. Get shader ID. Ahaha. There are some settings files that have the string normal to mean no shader. So we are screwed. I could do some... But how do I know if settings were created with an old version? I was thinking about retrocompatibility. Video mode. Video mode. Might have to simply change this one. Yes, okay, if I load a file with a video mode value, I can convert it to a shader mode value, to a shader name value. Okay, but not now. just open another issue. Okay. It was issue 1111. Maybe you can do something special for the end of the stream. Set video mode. I just wanted to compile, and I will finish this tomorrow. And another problem is that there are some video modes in the Solarus GUI, even from the Quest editor. Preferences. No. But in the launcher GUI, when you run a game from here, video filter. But actually, I will be able to detect the resource list from the quest itself and display them here. Okay, no problem. There's also a command line option called video mode, or is there? Wait, maybe not. Quest size? No, there's not, so I can rename it without breaking the compatibility, at least as far as the command line is concerned. Okay, it compiles. I guess it won't work. Okay, or maybe it will. So the display no longer adjusts to the window size. What is the video mode here? I mean the shader. It's no longer displayed. But, well, it must be the normal one, because I'm no longer loading it from settings. Okay, I will finish this tomorrow. Yeah. Enough for today. Removing built-in video modes. I have to push this to a new branch because I broke a lot of things. Shaders, remove video modes. Okay. Okay, I still have to think about what I want with video modes regarding retrocompatibility. I'm still not completely sure that I want to change the name in the Lua API. We will see. Okay guys, thanks for watching. I will continue the work on shaders. There will be a lot of nice things to show with shaders in the near future. I hope you enjoy this video and see you next time. Bye.